Divide the index into the exponent. The number of times the index goes into the exponent becomes the power on the outside of the radical, and the remainder is the power of the radicand. So we have the cube root of x to the 7th. So we rewrite x to the 7th as x to the 6th times x. 3 goes into 6 2 times. So that becomes the power on the outside. We have x to the 2nd power outside of the radical. And then whatever's left over in here, this x here, is left what's on the inside of the radicand. And that would be just x to the 1st power. Here, the 5th root of x to the 19th power, we're going to rewrite this as x to the 15th, which is a number that is divisible by the index. So x to the 15th times x to the 4th. And then we divide 5 into 15, which is 3. So we have x to the 3rd power out front. And then whatever's left is the radicand. As always, what about absolute value signs? An absolute value sign is needed if the index is even, the starting power of the variable is even, and the answer outside the radical is an odd power. Here are two examples of when absolute values are needed. Here we have an even index and an even exponent, 4 and 14. And when we finish the problem, we have x to the 3rd power, where 3 is odd. So we do need absolute value signs here. Here we have an even index and an even exponent, 6 and 8. And when we finish the problem, we have m to the 1st power. 1 is odd, so we do also need absolute value signs here. Let's try a few examples. All right, so we're going to rewrite this one as the square root of, we'll say 2 squared times 2, which is 8. 2 squared is 4, times 2 is 8. Now x to the 5th we'll write as x to the 4th times x. Remember, our index here is 2. So we're trying to get groups of number exponents that are divisible by 2. X to the 5th is not, but x to the 4th is. So then we have this leftover x. We're actually not going to rewrite y to the 6th because 6 is divisible by 2. And we have z to the 4th, which we don't have to rewrite because 4 is also divisible by 2. So this is the new way we're going to be doing this. So then we're going to handle this the way we did before. We'll just cancel out that squared, move this 2 out front. We have a 2 left over. Now we have x to the 4th. Instead of breaking this down into x squared squared, and then we cancel out that and move that out front, the shortcut now is just to divide 4 by the index, which is 2. So that would be x squared, and that's going to move out front. So I'm going to write the 2 that we are moving out front. Then we're going to move this whole thing out front. It becomes x squared because 4 divided by 2 is 2, so that's our new exponent. And then this is going to be left over inside because the exponent is 1. It's not divisible by 2. We move on. We have y to the 6th. Instead of writing y to the 3rd squared and then canceling out the squared and moving the y to the 3rd out front, now we can just take y to the 6th, divide 6 by 2, and that's 3. So our exponent is now going to be y to the 3rd power, and that's going to be out front. And with nothing left over. There will be no more y inside the radical. And we have z to the 4th. 4 divided by 2 is 2, so we'll have z squared out front. Then we have our radical and whatever's left, the things I've underlined, 2 and x. Now, do we need any absolute values? Well, we began with an odd exponent for x, so no matter what, we won't need absolute value signs around x. Y has an even exponent here, and in the answer, y has an odd exponent. So we do need absolute value signs. And remember, this is because also the index is even. If the index was odd, we wouldn't need any absolute value signs. But we have an even index, and we have an even exponent here, but an odd exponent in the answer outside the radical, so we do need absolute values. Z to the 4th, so this is an even exponent. But however, z still has an even exponent on the outside, so we don't need absolute value signs around the z. This is our answer. And there we have our answer. Only the y has absolute value signs because it has an odd exponent after we take it outside the radical. All right, moving on. We have 5y squared times the cube root of 16 times x to the 7th, y to the 4th times z. So let's rewrite some things that will make our lives easier. So 16 is 8 times 2. 8 has a cube root of 2. So that will be like 2 to the third power times 2. 2 to the third power is 8, times 2 is 16. All right, we have x to the 7th. Now we want x to the 6th because 6 is divisible by 3. So we'll have x to the 6th times x, because that is x to the 7th, y to the 4th. So we'll remove one y. We'll have y to the 3rd times y, because then that cube will cancel out with this cube root. And then z, which we cannot simplify further. We'll just leave z to the 1st power right there. Now we can immediately cancel out this cube and take this 2 out front. This 2 will be left over. Now, so let's write something. We'll write 5y squared, which is already out front, but we're going to add 2 to out front. X to the 6th. So 6 divided by 3 is 2. So now we're going to add an x squared out front, and there will be one x left over. We have y cubed, so we can cancel out that cube, take this y to the 1st power, move that out front, and then this y will be left over, and z just has to stay in there because we can't cancel out any cubes or anything. So then we have our radical. What's left? 2x, y, and z, everything I underlined. Now let's just simplify this. So we have 2 and 5, so that becomes 10. We have x squared, and y squared times y is y cubed, times the square root, or cube root, sorry, cube root of 2xyz. Now we check for absolute values. So this is an odd index of 3, so we won't need any absolute value signs no matter what. So this is our answer. All right, and there's that answer. Because the index is odd, we don't need any absolute value signs. Moving on, we have -2 times the 4th root of m to the 13th power times n to the 22nd power. So we're going to rewrite these with exponents that can be divided by 4. So we have the -2 out front, which I'll just put there, a 4th root of m to the 13th power. So if the next lowest number that's divisible by 4 is 12. So we'll write m to the 12th power times m to the 1st power, because 12 plus 1 is 13. We'll rewrite n to the 22nd power as n to the 20th power, because 20 is divisible by 4. And then we need 2 more, so n to the 2nd power. Now we can go and cancel things out. We have m to the 12th power, cancel that out, put an m out front. Our new exponent here is going to be 12 divided by 4, which is 3. Now, you might be thinking, this is odd, we need absolute value signs. However, originally m had an odd exponent, so we don't need absolute value signs. Only if the index and the original exponent are even, and then the outcome is odd, do we need them. So here, because this is a 13, we don't need absolute value signs. We do have an m left over in the radicand. All right, now we have n to the 20th, so we can cancel that out, put n out front, and 20 divided by 4 is 5. Now this is an odd exponent, so let's check and look. Originally we had an even exponent with an even index, and now it's odd, so we will need absolute value signs around that n. And then we have an n squared left over. So we have -2 times m to the 3rd times absolute value sign n to the 5th times the 4th root of what's underlined, m and n squared. And there we go. And there's the answer.